Hey guys, so my name is Stephen Tamman, and today I'm going to be kicking off a series here regarding learning how to program. So we'll get to some of the reasons why I'm doing this in a second here, but the basic gist of it is that I had a friend who asked me if I could help him learn how to code for his career. And having thought about it a little bit, I was kind of like, well, there's plenty of stuff on the internet, right? But I kind of thought, and then it occurred to me that I actually have kind of strong opinions about, well, the way that I think you should go about doing this. So the fastest, most efficient way to learn how to code, and in particular, as we'll go through today in the series, kind of talking about why I'm making this to begin with, one of the big things that I have strong opinions on and that I'm going to try to carry into everything that goes up on this YouTube series here is basically only trying to learn things that are actually useful in the real world. So this is something that's always kind of rubbed me the wrong way about a lot of education is we end up learning a lot of stuff that isn't really practically useful for us. So we spend hours and hours, years of our lives as kids and even as young adults in high school and college and even grad school, learning all of these things that aren't actually all that useful for us. And so if you are already a working adult and you're trying to pick up a new skill for your career, or you have a family to support or other things, well, you're willing to be a little bit more mercenary about things and say, you know what, it's great that we learn all the theory and stuff, but how about we learn the things that I can use tomorrow? Because in that circumstance, you already don't have very much time. And so I'm kind of the opinion that this is how we should teach people all the time. And then if anyone wants anything more, well, then you can dive into the theory and more of the depth in the background that has kind of traditionally been the province of education. But at any rate, that is a discussion for a different time. But today we're going to be talking about why I'm making this series. So I'm launching this series on learning programming, learning how to code, specifically this practical side of it. And today we're going to be talking about why I'm making this series and how what I'm planning to set out to do here is going to be a little bit different than many other online resources, and there's plenty of good stuff out there, by the way, but many of the other things on the internet regarding learning how to code. So this is the outline of the points I'm going to go over here in this first video in this series. So the first thing, which I kind of actually already summarized off the top of my head here, is going to be, well, why am I making this? Why me specifically? What's the origin of this? What things spurred me on to kind of start doing this? Well, after that, I'll be talking at a high level about how the series and teaching methodology here is going to be a little bit different, as I just said, from other stuff that's already out there. I mean, I'm going to kind of shamelessly copy things that I think are good. Also link to them, of course, not just plagiarize, but and try to make use of what's already there so I don't reinvent the wheel. But in large part, some of the approach taken here will be kind of different from most of the other stuff already out there on the internet. After that, I'm going to go through two of the big points here. This is getting kind of towards that idea that I had brought up about only learning the practical stuff. Well, 2 points here. Point one is we're going to try to minimize non-transferable skills. So stuff that you can't just take out and actually use as a real world software developer. Well, we're going to try to minimize that sort of thing. So knowledge that you're forced to learn that you can't really use in the real world. And then the other thing is we're going to try to minimize gaping holes in knowledge. So failing to learn things that are actually truly essential out in the real world as a developer, well, some of that stuff, as we'll get to when we go through this section, well, that sometimes happens in college. You'll learn a bunch of things that aren't useful, and then you'll fail to learn things that you really kind of need to be successful in your job. After going through these things, we're gonna answer that question, well, are internet resources better? And the answer is, well, it kind of depends on which ones. It's not like they're all monolithic. Things that model themselves on college classes will tend to suffer from the same problems the college classes suffer from, as we'll see, but even some of the better ones still aren't quite perfect. And then we'll go through some of those reasons why. So one of the first ones is a lot of these things still kind of teach people how to program the same way that people were taught how to program back when we only had terminals and we were all only learning C or Fortran or whatever. Well, some of that sort of thinking, some of those limitations that were put upon programmers in those days, for whatever reason, have been carried forward. So 2 examples here, making people debug with print statements and interact with their apps only using the terminal, so standard input and standard output. Well, those sorts of things aren't necessary anymore. We have IDEs with very good debugging tools that can really help you set breakpoints and understand the process and the flow of execution. And so it's actually very much more effective to debug like that. It just works a lot better. And then also, most things use graphical user interfaces. So it kind of doesn't make sense to have the primary means by which we have fledgling developers interact with their computers be command line, because, well, that's just not how it really works in the real world, for most people at least. And then, other points along these lines, why are we making people deal with package dependencies and downloading languages and stuff? If that's kind of a barrier to entry, and it is, it's complicated and it's one of the ickiest parts of programming, honestly. Well, we have online IDEs and online development environments that will handle all that for you, where you can just copy paste in code and press play, and then it will run it for you. And you don't have to worry about setting up the packages and stuff. So this is another beef I have with most programming teaching resources, is that they start out making people download packages and stuff. And then another one here, the tendency to discourage people from being clever and finding code that already exists out there. So essentially copy pasting code off Stack Overflow. Well, that's kind of highly disincentivized in the learning process. And part of this is because, well, people need to learn how to actually code themselves. But the tendency, I think, is quite a bit overemphasized, because in the real world, in a production environment, when you're on a team, you will try to use everything in your power to copy what already exists, right? We do copy paste code off Stack Overflow. And we have to modify it and tweak it and make sure we're only using things relevant for our circumstances and stuff. But the tendency to kind of get angry at students for doing this, or to kind of punish them for being clever and using a library to do the programming assignment, I really think that it tends to instill the exact opposite of what you really want to instill in programmers, which is you should always try to use something that already exists, something that someone else has already written, a library that already has tests for it, that's been vetted, that's under active development, and has lots of other eyeballs looking at it to make sure that the code does and works how it says it is. Well, that's a lot better for you to use than having to write code yourself and maintain it and test it yourself and all of that. And so it's just kind of emphasizing the wrong thing. Another point here, well, we don't force most students in the sort of teaching environments that many people learn how to code in. So even these online resources, and it's kind of what we're going through here, well, even many of these online resources don't really have students build upon the code base that they've already written. So they kind of jump from project to project, and they never have to deal with any of the code they wrote before. And it lets people get away with not really learning how to do software maintenance best practices. So how to develop a code base that is well maintained, easy to read, well organized, and has good documentation. Well, all of that stuff is completely essential in the real world. But even these programming classes on the internet that perhaps are more on topic and teach you mostly only relevant practical things, well, even they still suffer from some of these things here. And then we're going to close out today just by making the point here that, by way of contrast, what we're going to try to be doing here in this series, and of course I won't be perfect in it. I'm not a professional teacher. I'm actually a software developer myself. So, I of course don't know all there is, and I don't want to pretend that I'm someone greater than I am. And that will be the focus of the next video, just kind of talking about me a little bit and my background. But nonetheless, what we're going to try to do here is pick up programming and learning how to code basically as actual software developers do it. So without learning extra stuff, without failing to learn stuff that's actually important, without getting stuck in the past, being constrained by these things that are kind of arbitrary, what we're going to try to, as much as possible, learn how to program like actual software developers program day to day. So that's going to be the goal here and the focus. So you can kind of keep that in the back of your head as we go through all the things leading up to this point here. So the first thing that I'm going to go through is kind of why this series. Why am I making it? What was the impetus behind making this set of videos that I am here? And the gist of it is that a couple weeks back, a friend asked if I could help teach him how to program for his career. And at first I was kind of like, well, I learned how to program off the internet, more or less. I had a couple classes in college too, but I really did mostly teach myself. And I know a lot of other people that did too. So kind of, well, why do you need me? There's all of these great things on the internet, and I could go send you some links and you could go read it, and then you could go teach yourself. And, then I wouldn't have to spend time doing it. I'm lazy, right? But as I thought about it a little more, I kind of frowned and realized that I kind of actually have strong opinions about this. And I kind of don't agree with how beginning programming is actually commonly taught. So with the pedagogical approach often taken for teaching people how to code, I actually really don't agree with many of the ways in which it is commonly done. And so given that, I kind of felt compelled to, well, you know what? I could recommend some things to him, but I'd always kind of have to put an asterisk next to it and say, you know what, I don't agree with this bit or this bit or this bit, but hey, you can read that, and maybe that would be okay. But I did kind of decide, you know what, I have opinions on this. Maybe it won't hurt for me to go ahead and make a series of my own on it. Now, because there's already so much out there, there's people a lot smarter than me doing this as well. I won't pretend that what I'm going to be going through is going to be absolutely the best way to learn programming or, things along those lines. It completely depends on the person and what they are interested in. So, software engineering is a very broad field. There's a lot of things you can do with it. So just for example, people who develop mobile apps for phones are going to be worrying about a completely different set of problems than people who develop web-based applications. And those people will be worrying about a completely different set of things than people who are developing operating systems. And you get the idea, right? So it really does depend on what you're doing. But nonetheless, we are going to try to be putting my own spin on this here to try to make sure that we pick things up in a practical way. And so basically what I'm going to be trying to do is teach programming, so how to code and pick up the basics in the way that I personally wish I'd been taught. So going from ground zero, not knowing anything at all, to at least basic proficiency. Well, the point of this series is kind of going to be doing that in the way that I think would have saved me the most time in preparing me for the workforce and what I actually do as a software developer day to day. So the fastest point from A to B without ancillary things that really aren't useful and without neglecting to talk about anything that really is useful. That will be the basic goal of this series here for us. So with that introduction out of the way, the next thing that we're going to talk about here, and this is kind of what will be on the rest of the day, is, well, how is this series and teaching methodology going to be different from the ones out there that already exist? And so from here on out, we'll kind of go through the things that I think will make this series a little different from how most other programming teaching materials do it. Not all of them, but there will be some differences here and there. And this will be the place where, the one and only place in this entire series where I'll note that not everyone probably ought to do things exactly this way. So I'm going to be unapologetically opinionated, and very much so most of the time here, but this is the one place that you hear me kind of be wishy-washy about things. And so in that wishy-washiness, here's the sentence that you really should keep in the back of your head as we go through everything here. And so that is that this approach, the one we're taking here, is probably not right for absolutely everyone. So people should weigh their own personal circumstances and so on when deciding on how to do things, as there's no such thing as one size fits all. So this is kind of the lawyer speak here, that I'm going to be going through what I think and actually believe to be the most effective approach. But of course, me and my background and my experiences and all of those things, well, they're not completely the same as everyone else's. And so just because I think this is best does not mean it's actually so for all people across all circumstances. And you get the idea. Now, you can sort of keep this thing in the back of your head here. So this idea that this may not be completely right for everyone, may not be right for you. Well, you can kind of keep thinking through that as we go on here. The main reason why I'm kind of making a big stink about this up front is because I could always be leaving disclaimers everywhere, basically like, this is only my opinion, your mileage may vary, things like that. But I kind of think it's more effective to just make the point very strongly up front here. This point, by the way, which I completely agree with, that there is no one size fits all approach. Everything that we go through here may not be completely the best for everyone. But rather than do that and always have to say your mileage may vary after I say absolutely everything, I'm just going to make the point up front here and then just present what I really think without constant comments to this effect. So basically, I'm going to give you my opinion, is what I'm saying. Now, usually I have what I would like to think are reasonably decent reasons for thinking things, but nonetheless, this approach that I'm saying is going to be heavily colored by my background and my experience. And so people should just bear that in mind as we go forward with everything here. All right, so the next thing that we're going to talk about, and we're going to spend quite a bit of time here, is talking on this idea of how we're going to try not to pick up any skills that we can't really use. So non-transferable skills. We're going to try to minimize the amount of non-transferable skills that we learn. Now, I'm going to be talking mostly from my perspective here, having gone through and gotten a bachelor's degree in computer science from a university. And different colleges, I'm sure, are different, but I think most of them do it pretty similarly, because I've taken online classes from, like the edX platform, so from MIT, and I went to the University of Georgia And I actually went to Georgia Tech for 2 years, kind of a long story. We'll get into that a little bit perhaps. But in all the universities, they all teach it pretty similarly. So what I will call like the college experience here. Well, I'm going to be coming at it mostly from that point of view. But many people do pick up programming in the workforce, and those people will have a slightly different point of view, but some of the things will carry over. So we're going to be talking about trying to minimize non-transferable skills, and you'll get a feeling for what I mean by non-transferable skills as we go through some of the slides here. So the first example I'm going to use is the interface that we were taught in our development classes in college for Java. So Java was the programming language that they started us out with. So that was our first and second semester programming was all Java. It is one of the more common object-oriented languages, and so it's not that surprising here. But the thing that is kind of surprising is that what we spent the most time on interface-wise in college was this thing called JavaFX, where we built user interfaces for desktop applications. Now, my knowledge isn't the best here because I'm mostly a C# tech stack guy right now, so the Microsoft platform using SQL Server to C# as an API backend and then deploying to Microsoft Azure and all that. Well, that's mostly what I do at my day job. So I don't actually know all that much about professional Java development because I never really used it outside of college. But with all that disclaimer out of the way, to my knowledge, the most common interfaces that are actually used for Java in production environments are the Android software development toolkit for mobile apps, so the Android SDK, HTML templating in a Java MVC web framework. So this is web apps if you're doing client-server architecture where you're actually having the server render web pages. Well, you might use a web framework like Spring, that's a Java web framework, where you do most of the front-end stuff in HTML and CSS and JavaScript. Or you might use a full JavaScript front-end. Now, this is actually what I use at work. We use Angular at work, but the three big ones are React, Angular, and Vue, and there's others like Ember and stuff as well. But in that case, you'd be doing the interface with JavaScript, with a JavaScript framework rather than Java. And so the thing is, these three things, to my knowledge, are actually the most common interfaces used in the real world. But the thing is, we didn't learn any of those when we were in college picking up programming. In my second semester programming class, we spent a fair bit of time, and by that I mean like a couple months, learning how to build desktop Java apps with JavaFX. So JavaFX kind of has its own way of laying out elements on a user interface like buttons and text fields and things like that. And there's nothing wrong with it. I mean, I want to be perfectly clear about that. It's not like it's terrible or inefficient or anything like that. It's just kind of niche is all. So the gist of what I'm saying here is that I think all of the time that we spent here in college learning about this use case here probably could have been better spent if we were learning something that is actually more relevant in the real world. And that would be one of these other things that, to my knowledge at least, are more common in actual production environments. Now, if I'm being perfectly honest, I think much of what we learned in college had a focus on desktop. So desktop operating systems and learning how to build desktop applications, which given that our modern times here in the 2020s seems kind of silly because mobile and web are honestly where most people are going to find themselves as software engineers after they graduate. And so it kind of makes sense, in my opinion, if what we teach students by default isn't the desktop perspective, but mobile and web instead. Now, that's, again, kind of another side tangent here. But this is my first example here. So in college, rather than learning something like a Java MVC web framework or interacting with the Android SDK or even learning a JavaScript front end to interact with a Java API, well, all of those things are kind of how most Java apps are deployed in the real world. But rather than learning something like that, we learned this thing that, as far as I've been able to research, just isn't used as much by most production environments, at least given our modern times. And so this is my introduction to the point here of this is the sort of thing that we're going to try to avoid. We're going to try to avoid teaching things, maybe because of history or because that's how it's always been taught or whatever, that aren't actually used in the real world. So the goal is going to be to avoid things that don't bring you practical, real world value as a software developer, because quote unquote real devs don't use that. Now, you have to be a little bit careful of no true Scotsman here. I'm sure there are actually people in real environments that use this. The whole point that we're bringing up, and you'll get this as we go through some more examples, is just that it's kind of all about probability and statistics. So some things are used more frequently than others. And what it kind of makes sense to institute as quote unquote what you teach students is going to be the things that aspiring software developers are most likely to actually use in their careers. So the things that statistically have the most frequent usage and are most likely to actually be relevant and applicable to people. Now, especially web and mobile, well, both of these things change at a very rapid rate. Frameworks come and go, and approaches come up and then die off very rapidly. So things are changing. And that is perhaps why some universities are kind of gun shy about adopting any of these things, because they say, well, what happens if we pick something and then it kind of falls out of fashion a few years later? Well, then we have to go rewrite our whole curriculum and stuff. And you can kind of sympathize with that point of view. But nonetheless, we really do want to be teaching people things that are actually useful and relevant in the real world. So now, this example I brought up here with JavaFX, well, this was just my opening example. I got slides and slides on this, man. So this example here, it sounds bad enough, right? That we spent all of this time, months even, learning this thing that isn't really applicable in the real world. Well, that's actually closer to the more practical side of things that we did in university. Now, this is going to sound super harsh. And this isn't a critique of my university in general. Let me be clear. This is a critique of how programming is taught in higher education in general, is that most computer science classes in college have almost zero applicability to what real software developers actually do. I mean, like I said, sounds super harsh, but I think this statement is mostly true in most circumstances. So if you are presently a computer science student in college and you've ever had that sneaking suspicion, basically, are we ever actually going to use this? Students ask teachers that a lot, right? Well, it's actually probably even worse than you thought, a lot worse, because most of the computer science classes that you take in college, this is my N=1 experience, by the way, as a full stack web developer. Well, most things completely useless. So I'm going to go through a whole bunch of examples here. I'm going to kind of go fast because, you can certainly read the paragraphs if you like. But one example here is systems programming and operating systems. So I had 2 or 3 classes on these things. And even with that being the case, I will probably never touch a line of C code again in my life. I'll never have to deal with pointers or passing by reference and all that other great stuff that's mostly C specific because, well, most people don't develop application level things with C. C drives operating systems, and maybe if you have to write drivers for something or whatever, you write it in C. But people who develop applications for clients, well, they don't use C. And so why do we spend multiple classes teaching people C and how operating systems work? Now, there are instances, as I want to be clear here, where if you want to work in a specific area, well, then you're going to need to take these classes. If you ever want to go help develop the Linux kernel, for example, you're going to certainly need to know C, and you're going to need to understand how operating systems work and the process scheduler and how CPUs interact and all of that other great stuff. But just for most people aren't going to do that. And so why is it a requirement is basically the question here. Now, that's one thing, but we were actually required to learn assembly as well. We had to take a computer architecture class, and we learned MIPS assembly, so how the CPU processes instructions. And so even more than C as a programming language, how many people really need to understand how registers and computer processors work, how the task scheduler organizes and parallelizes work across computer processors? We learned about all of that and how pipelining works to increase how many instructions can be run by the processor and all of these other things. Well, I certainly don't use a lick of this in my job. And all of my friends that I've kept in contact with from college, right? People who work in industry in a wide variety of different companies. So some of them work for banks, some of them work for like startups, some of them work for tech companies. Well, down to a person, nobody uses this. Because most people write in higher level programming languages where they're actually building stuff for clients, right? They don't deal with computer processors. Now, I have one exception. I have a friend who works in a research lab who does some like malware analysis stuff where they use decompilers, and he actually works with assembly, but most of my friends from college don't. And yet this was a requirement. We spent months, perhaps even years, depending on how many classes you took, learning about this stuff. And so just as a side note here, most of this stuff is super hard and complicated. So I'm plenty humble enough to leave all the hard sort of tasks to the really smart people. So hardware and kernel and compiler design and all that great stuff. Like some of the stuff that compilers do is absolutely insane. Some of the optimization and all of the clever stuff they do to make code compilation more efficient and more productive. Well, I'm going to leave that to the geniuses, and I'll just happily stand on their shoulders in ignorance here. I'm going to say, thanks, super smart people, right? Because I can use the things that they did without having to actually understand it myself. And that's going to be the contention that we're using here. Programming relies on this idea of encapsulation a lot, of viewing code as a black box, knowing how to use it rather than understanding how the implementation works. Well, and I'm arguing here that we should view learning programming that same way. We should learn how to use things rather than how things work per se. I mean, you need to know how it works at least a little bit, like networks, for example, if you're a web developer, but you can kind of leave the icky bits to the people who are really smart, who actually design these systems here. All right, so now I'm going to go through even more examples here. So databases class, right? We didn't actually learn very much SQL in the databases class. Anything complicated like, you want to order by something and then select this subset and then do a subquery or stuff like that you'd actually learn in the real world. Well, instead, we spent most of the time on relational algebra. So we were learning the mathematical basis for relational database management systems and how the query optimization is done automatically. Why? Because we don't use that in the real world. So why do we learn it? How about networks? So we didn't learn how to create HTTP requests in different development frameworks. So, like front end versus sockets on a local application going through a firewall or anything like that would actually be useful. Instead, we spent a lot of time learning about the routing algorithms that run on network switches somewhere on the internet. So the things that connect all of these routers and switches together on the global web of networks that forms the internet. But the problem is, well, we will probably never see these algorithms or care about them unless we work for Netgear or some other company that makes routers or whatever. So why do we learn it? How about data structures? Now, data structures and algorithms, these next two, these are like the classes, boy, everyone says you have to take data structures and algorithms. You need to be good at data structures and algorithms if you want to get a good job. Like you'll hear this a lot, right? But data structures in college, at least the class that I took, it didn't actually teach us that much about how to use different data structures, like when you might want to use a linked list versus a statically allocated array versus a dynamically allocated array, so stuff like that, where you use this one in these circumstances for these reasons. Well, we didn't learn so much about that, but we actually created the data structures ourselves in C, right? And which, like we talked about, well, no one really uses C for application level development. So why, right? Why did we create these data structures ourselves when libraries already exist that do it in a much more optimized way than what we would possibly write ourselves? So you can understand them at a high level, and that's great and all, but really what we care about as programmers, as actual real world software developers, is how to use them, not how you build them. And algorithms is the same way, right? So we didn't learn about how algorithms are used in certain fields. So a couple examples I gave here, like machine learning, there's some complicated algorithms dealing with these huge data sets that they feed to AI programs. Or how about stream ciphers and encryption, right? That's super important in cybersecurity. How can we make encryption performant, especially encrypting and decrypting web requests and things like that? Well, these things are niche, right? Not everyone's going to need to know these things, but at least people actually use them in the real world. But much of what we talked about in algorithms was way more theory than that. So we learned about, things about traveling salesmen, right? Traveling salesman problem, the halting problem, mathematical analysis of algorithmic complexity, and lots of proofs. So a very small number of brilliant people will work with these things, right? And these are the guys, the really smart people, like I said, whose shoulders I'm happy to stand on. These are the guys who will build the nicely wrapped packages that the rest of us use in ignorance. So the problem isn't that these things aren't important or that someone doesn't need to know them. The real problem is, well, why do we recommend this class to all students instead of the small few people who will actually benefit from it? And like I said, data structures and algorithms, these two in particular, highly pressured into taking them in a university environment in college, because they say, well, that's what employers want. You need to be good and strong on these things. And my contention is, actually, based on what they teach in the classes, most of this doesn't help you at all. Yes, you need to know how to use data structures and you need to know how to use algorithms, but these things in a high theoretical sense, not applicable in the real world. Maybe applicable in academia, but not if you work as a software developer, it isn't. So why? That's what we are asking here. Why do we learn all these things rather than the practical side of things that would actually be useful for us as software developers? So I could keep going on with even more examples, right? I've just taken some of the classes from college, right? Now, like I said, I'm a little bit biased here because I'm a full stack web developer. So, my area of focus will not be 100% the same as other developers. Mobile people would probably actually benefit from an Android or iOS development class, while I wouldn't because I'm not an Android guy. I develop web apps. You get the idea. But even given that, I basically only used 3 and only 3 classes for my entire college. And I took, 15, 20, some odd, lots and lots of classes, but I really only used stuff from 3 of them in the real world. And those 3 are Intro to Programming 1. So this is the basic stuff, loops, conditionals, functions, classes, that sort of thing. The second one, which is the object-oriented class, essentially. So object-oriented programming, the core tenets of object-oriented, so inheritance, polymorphism, overloading functions, that sort of thing, Lambda functions, generics, right? This is kind of like the follow-on class. So what I consider, again, just kind of core programming skills in an object-oriented framework. And then the third class is web development. So HTML, CSS, JavaScript, and the web tech stack, right? Also how HTTP requests work, how you make AJAX calls to a server, things like that. So I wish I was simply exaggerating here and saying that I only use 3 classes, but I'm really not, like not at all. I legit only use things from these 3 classes, which means that I spent approximately 3 years in college learning all this other stuff that I just don't use. They were almost wasted in terms of what I actually do as a real world software developer in my career. So I would have much, much rather spent the time that I was forced to spend learning these other things, right? Basically, how computers work theoretically, the theoretical basis behind computation. You know, we actually, a class I didn't mention here, perhaps even more on the not useful scale, is like theory of computation, learning about deterministic finite automata and how computers work on a theoretical mathematical basis. Well, all of these things that we learn, well, I would have much rather instead learn JavaScript front ends like React or Angular, you know, modern unit testing frameworks. Unit testing is something we barely did at all in college, and best practices in unit testing and test-driven development and things like that. Or, you know, countless other things. I could just go right off the top of my head and tell you all of these other things that I actually use day to day. Well, I would have much rather learned stuff like that. These things that would have a much higher probability of actually being used by me day to day as an average software developer, right? Now, you can't be perfect, right? Because people will specialize and go into different things. But the point is, it kind of makes sense to teach people things that they're actually statistically likely to use, right? All right, so that was the first point. That was us learning a bunch of stuff in college. And as I said, I came at this from the university perspective because that's my background. But from my understanding, this is true in a lot. Many resources that teach people programming end up teaching them a lot of theory, a lot of stuff that's just not super useful if what you're after is like a practical working knowledge of how you program, how you code. You just don't need to know a lot of that stuff. Just how we're comfortable with encapsulation in the rest of programming, so too should you be comfortable with it in the process of viewing everything below what you're doing as kind of a black box. You just need to know how to write the high-level code, and you don't need to care how it gets compiled down or translated or turned into assembly or how the CPU runs it, because at a high level, well, it's just not going to bring you any added value. So that was that. But now what we're going to talk about is minimizing holes in knowledge. So these gaping holes in knowledge that come also from only focusing on the sorts of things that really aren't useful in the real world. So on top of learning a lot of things that aren't useful in practice, and again, I'm coming at this from the university perspective, well, we also didn't learn many things that are actually essential for real world software development. So one example here, we learned how to use command line Maven. So Maven's like a build tool for Java, at least we used it for Java. And we also learned how to do make files. That was mostly in our C classes. Well, we learned how to use command line Maven and make files, but we didn't learn how to set up and scaffold common types of projects based on pre-made templates. Now, here's the problem. In the real world, we, and I'm speaking with the collective we here, most average software developers don't handwrite make files. That's not a thing. Like, we don't sit there and type them out. I mean, some people are exceptions, of course, but most teams start out with their projects based off a template. So maybe you have a template for a web application or a template for a desktop application in the .NET framework, which is desktop only. For example, if you're in the C# tech stack like I am, or any of these other things, well, you'll start off with a project template for a common use case, and then you'll let the template handle the icky boilerplate and the package dependencies and the build file and actually building and linking the projects and all of that. Well, you never touch that, not in the real world, because it's time consuming and error prone. So why would you let a human do it if you can let the build tool do it for you? And so this stuff that we learned in college, we learned the wrong thing. What we should have been learning is how to scaffold projects based off templates and how to get a working project up and running in 20 minutes, because that's actually possible. And then you add things to it, and then you don't have to worry about it. So we spent hours and hours and hours doing this when really what you use in the real world is something completely different. So why didn't we learn how to do the project scaffolding instead? You know, what real world developers actually use. Kind of makes sense for us to do that, right? Yet we didn't talk about it at all in college. Here's another one. How about production environments where you make your code actually usable by other people? So we never learned about integration testing and production environments, right? How to handle managing and sustaining a production database, writing scripts to update it or patch it or run migrations against it, dealing with external Saml authentication endpoints. You know, if you have something that authenticates that's external to your application. So I work for the Air Force, and we have basically a centralized authentication server based on people's Department of Defense IDs and things like that. So we have to deal with an external SAML authentication server. Most people might run their own internal as well, but dealing with authentication, applying user roles and permissions to app functionality, that's authorization, or any of the myriad of other things that are actually essential to building applications that run in a live production environment that are actually usable as applications in the real world. So here's the scary thing. Unless your app is local only and without users, right? How many of these are there? I mean, there's certainly some applications that are like that, but not many, not in our modern world. Unless your app is local only and without users, coming out of college, you'll actually be completely incapable of making a software product that's usable in the real world. Like just think about that for a second. Let that sink in. Out of college, you will be completely incapable of making a software product that's usable in the real world because they teach you none of this, none of having an app in a live production environment that actually handles users and roles and stuff like that. We didn't even get a taste of that in college. And yet a lot of being a software developer is related to this stuff, right? So gaping hole in knowledge, as I say, this is what you actually do as a software developer. That is not what you spend any time learning in college. So some more stuff here. This one makes me laugh a lot, actually. We never learned any bit of version control formally in college, like not a single time in class. They certainly weren't against us using Git for our projects, although, of course, we had to have private repositories to prevent cheating and plagiarism and stuff. But we never formally learned any bit of version control in college. Like, I use Git all the time at work. Like, when I say every day here, I mean like 50 bajillion times a day, right? You commit, you merge, you push and pull from the development server that you share with your team, and all of this. And so version control, in my correct opinion, essentially is essential to team-based software development. Like, you can't do it without version control. It just doesn't work. It doesn't have to be Git. Some other teams use Subversion or Mercurial or whatever, but Git is probably by far the most common one here, right? And so, like I said, this one makes me laugh a lot because modern software development would be completely impossible without version control. And yet, from what is focused on in college, you never know version control even exists, right? Much less that it's a fundamental part of the software development process because they just don't talk about it at all, right? It makes no sense to me. And so how about this one? This one's arguably even more important, right? We never learned much about how to select what language, tool, or framework is best for your use case, right? In my opinion, this would make a great class to do. Like, basically, when do you use what? And how do you know? And how do you make decisions about what tool to use? How active is development on it? Do they have developers who maintain it? Is there an active Gitter channel, right? Do they have a Discord server where you can ask them questions? Because you only want to use things in a production environment that are going to be well supported long-term. Or how about this tool's capabilities versus that tool's capabilities, their pros and cons, how fast it is to learn, right? So for example, I use Angular at work. Angular and React are probably the two biggest JavaScript front ends, and there's lots of pros and cons to using them, right? Like, you might use one in one set of circumstances and the other in a different set, but how do you know, right? Like, we learned none of that, which is arguably super important in the real world, because if you get things wrong here, you can kind of almost practically doom real world software developments right from the start. So if you use a tool that no one on your team has any experience in, for example, then what happens when you get stuck and you have a question and you Google it and you can't find the answer to it? So just for example, my team, when we were developing the application that I'm on most recently, well, we had a choice between multiple front-end frameworks. We knew we were going to use C# for the API, but we could have used React or Angular or Blazor. Blazor is a new front end that uses WebAssembly, which means it's actually pretty fast because unlike JavaScript, which runs in the browser, it actually runs on the CPU. Well, a lot of us were really interested in Blazor, but the problem is we had nobody in our entire group. So like, not even my smaller team of 10 or 15 people, but like no one in our entire building had any Blazor experience. So if we picked it, project would have been doomed, right? Because inevitably we'd get to a point where one of us had a problem and we couldn't figure it out and no one could figure it out, and then we're stuck. But we did have people with Angular experience, like 3 or 4 other teams that work in our building had Angular experience. And so in the early days, when we were all learning Angular and going through tutorials and stuff, well, if we got really stuck, we'd go bring it to one of the smart guys, one of the senior devs on the other teams, and be like, okay, I can't figure this out. Can you help me? And then what was impossible for us, they'd figure out eventually, right? And so that sort of thing, right? Who knows what in your organization, what is the easiest thing to learn? All of these things completely essential in a real world software development environment, because you have to make decisions about this sort of thing. Like, what do we use? What packages do we use? All that stuff happens all the time, but you never learn a single thing about this in college. And again, as I said, college isn't the only thing. My impression of learning how to program from, like programming courses on the internet, not so different from college in this regard. a lot of the times they fail to teach you all of these things here. And so these things are just examples, right? Just as in the first case. The main point is that for whatever reason, a lot of programming pedagogy is stuck in the equivalent of the Stone Ages. So back how it used to be 20, 30, 40 years ago. And it doesn't really account for what is actually done by software developers in the real world, which if you're trying to become a software developer in the real world, well, it's not so good for you, right? Because you're not learning a bunch of things that you really need to learn to do your job effectively. And so you might ask, given all of this, are internet resources better, right? So first point to make is just ones that emulate college courses. Well, they really aren't. So I'm speaking from some degree of personal experience here, and that I took a couple of intro courses to teach myself Python over my freshman summer. So after my first year of college, since I was going to be in a higher level Python class the next semester, and I'd only learned MATLAB. And we'll kind of get to my history again. That'll be the next thing in this series here. But basically, I had to teach myself Python on my own because I was taking a high level class in it and I never had the language before. And so I went on and I took a class on edX, which is one of these massive open online courseware sites. Coursera is another example here. But the problem with these things is that they still can't seem to teach you introductory programming without injecting a bunch of unnecessary theory into it. And what I mean is they teach you a whole bunch of history about how computing came about, and they teach you binary and all these algorithms, like they make you code out binary search and do recursion and stuff. And so here's the thing, normal devs don't need to know tail recursion, right? Maybe you use recursion if you're using like tree traversals. There's like 2 or 3 cases in all of practical software development. The rest of the time, if you try to check in recursion into your code base, you will get torn apart in peer review. No one will say, oh yes, let's do the recursive way rather than using iteration. Like you'll get torn apart. No one will let that actually into production code. Now, like I said, there are some things with trees where it actually makes sense, but most of the time doesn't, right? So why do they spend weeks and weeks and weeks teaching recursion? It doesn't make any sense, right? How about mathematically analyzing the complexity of code, right? Doing the O of N analysis on something. Well, you can learn how to do that mathematically, but the thing is, it takes a lot of time, right? Sometimes you even need calculus for it. Well, do we do that in our production environment? No, of course not. The closest we get to optimizing our code like this is we run a profiler on it. And we say, oh man, this section is really slow. How about we reorganize it? We'll do this for our database queries too. We'll say, you know what, we're doing this nested subquery and that's really dumb. We should think about this more because, that's going to hit like 100,000 records and it's going to be super slow. So like we do optimize our code, but we don't sit there and do it mathematically. We run a profiler on it and they say, okay, this is the slow section. Here, someone go take a look at this again, scratch your head and try to figure out a way to do it faster. And sometimes, even if it's kind of slow and inefficient, well, if it's easier to maintain, we'll still do it the slow way because sometime in the future, someone else is going to have to read our code. And if we did it a really confusing way, well, then they're not going to understand it. And that's bad. So not to get too much more into it than that, the problem here is that many of these classes that teach programming on the internet, well, in as much as they're just translating college classes, which have all these problems as we've gone through for the last 20 minutes or whatever, well, they have all those problems too, and that's no good. Now, many other online resources, so I give 3 examples here. Code Academy is completely free, very excellent resource by and large. Well, many of these things are noticeably better, right? So you can pick up Python or programming language you want, basic introductions to programming that really don't have a lot of fluff. They stick to only useful things for the most part. But the problem with these things, also Pluralsight and Treehouse, these are more business focused, right? I think both of these cost money actually. We have Pluralsight at work. So this is actually where I learned some of the stuff at my job because they were like, okay, you need to go use this package. And then rather than going and bugging a senior dev on my team, they say, here, go watch these videos. Most of the time it's pretty good, right? Especially if you're already a programmer. So again, they stick mostly only to useful things. They don't suffer from all of this advantage because you can kind of pick and choose and learn the stuff that is more useful. But they do have certain other issues. And this is my beef with teaching programming in general. Many of these things, again, many, not all, depends on the course. Some courses are much better than others too. There's a different standards of quality across these resources. Well, but some of them still kind of have these carryovers from the old days that kind of don't make a lot of sense in my opinion. And you'll see what I mean here in a second. So probably the one that gets me most, that makes me most annoyed, is that in these classes, even these otherwise better ones on the internet, they still teach people to debug with print statements. Makes 0 sense in my opinion, because in the real world, we don't use print statements. We use integrated debuggers all the time. So my job, like I say here, it's really fun to teach the new guys how to use all the powerful debugging capabilities of modern IDEs. Doesn't matter which IDE it is, if you're in Visual Studio or VS Code or IntelliJ, if you're a Java guy or whatever, it doesn't really matter. All of these modern IDEs have really cool powerful debugging capabilities, such as I say here, the ability to change local variable values to whatever you want when you're paused on a breakpoint. Well, that can be super useful if you're trying to figure out what your code thinks is doing, right? If you want to like fake a value, essentially, you can just pause program execution and then change what it is in memory right then and there. Super, super useful, right? But you can't do that with a print statement, right? So as I say here, you can literally watch their minds get blown, right? It helps so much when you're trying to debug your code to use some of these powerful capabilities, but they just don't know it. Like I said, it makes me grin. It's really fun teaching people this because suddenly they have all this power that they didn't know they had. So I do understand that debuggers are IDE dependent. So they're different across different programs. You have to learn how to use them. There's a bit of a learning curve to them. But in my opinion, it's straight up criminal to teach people how to program with debugging only through print statements. So the analogy I'm using here, it's like trying to tell an architect that he can use whatever tools he wants for his job, except he can't use a mouse with his CAD program. That's literally how crippling it is. Because of course, architects use CAD programs all the time now. And if you don't give them a mouse, well, their hands are kind of tied, right? Maybe they can still do it, but they're going to be much less effective than if you let them use everything at their disposal. And so that's the sentiment here, is that debugging is much, much better if you use more than just print statements. That's a big part of tracking it, but it's very time intensive too. And the ability to have breakpoints and pause and continue and step over and step into stuff, well, debuggers are super duper necessary. How about this? Making people interact with their programs via the terminal. So standard input, standard output, writing to the command line. So with few exceptions, real world applications all use actual user interfaces. So buttons and text boxes and that sort of thing. So the fact that interface design is not incorporated from day one, it just doesn't make any sense to me. Now, I understand, again, sort of why people do this is because it adds a little bit of complexity when you have to teach people how to make buttons and lay them out on the page and things like that. But here's the thing, is that does that add some complexity? Is it a bit harder? Yeah, sure it is, but it's not that much harder. And here's the real rub of it, is that it's a much, much, much better representation of what real world programming is like. Because in the real world, if you tried to give a client a terminal application and say, oh, okay, just read the man page for it. You think that's going to be acceptable, right? You think that you can make a terminal application and give it to normal people, the people who actually pay for software. It just doesn't work like that. That's just not how the real world works. And so why then is that how we teach people programming? Why do we only have them make these programs that run on the terminal, the command line, when in the real world, they'll never make a program like that, not once. It just doesn't make any sense. So I have several more slides here. I know this is getting pretty long, but several more slides here on these other things relating to teaching programming in a way that just doesn't match reality as well. These things that even some of these better resources occasionally suffer from, although not all of them, just some of them. So we started out talking about here with debugging and interacting with their apps only using standard input and standard output, right? Rather than actual interfaces and teaching people how to use interfaces and design them. Well, next thing, why do we make people deal with all of the package and dependency stuff, right? It doesn't make any sense for new developers to deal with this, because arguably this is one of the most complex and error-prone and icky parts of software development, is figuring out and wrangling package dependency, especially when people update their versions and then your code breaks. It's no fun, very unfun part of programming. Well, the problem is many teaching materials out there on the internet, they start, the very first thing, lesson number 1, will be getting people to download a programming languages and its packages, and then set up path variables, like environment variables on the path and stuff, because for whatever reason, sometimes the installers don't do that. So what I'm saying here is, if you ever tried explaining the differences between Python 2 and Python 3 to a non-technical person, I mean, heck, I've tried explaining it to technical people, and sometimes people still get really confused, right? How about the fact that you can run both of them at the same time in different Python virtual environments? They'll say, well, what's a virtual environment, right? Then you have to explain that. This just, basically, it's just not the best place to start people, right? Some of the stuff you say, oh, well, it's necessary for programming. And see, the thing is not, because online development environments, I have this link here to, I think this is from Medium. No, whatever. It's, some blog about programming, right? And so on this, the guy compares a whole bunch of these online IDEs where you can just go run code in your browser and you don't have to worry about setting up packages and dependencies and all this other stuff. So it's just my opinion that this is way more effective to just go get people programming, just send them a link and say, hey, here, go write your program, go write a while loop, and then they can do it instantaneously. They have to download nothing, right? So why isn't this how everyone does it, right? If the focus is on learning how to program, well, people might say, But people are going to need to know how to do this in the real world. They're going to need to know how to manage packages. Well, in the real world, we all use package managers anyway. So I use NuGet. Again, I'm a C# guy. So we'll do something like install package name, and then that's it. So no, they really don't actually. And the truth of the matter is that when you get hired on somewhere, so especially if you work for a company, you're most likely not even going to personally have to deal with installing dependencies anyhow. You'll probably get a laptop built off a standardized image. So, like Windows 10 image, for example, that is a company-specific managed software distribution. So they'll have, like, for example, this version of Java and this version of Python and this version of Node and so forth. And then what you'll do is you'll clone a repo, set up an SSH key to push to and pull from your dev server, and then you'll run your build commands, so like npm install, for example, then off you go. So you won't actually have to set up software dependencies yourself because the IT guys will do that. So no, you really don't need to teach people this. It doesn't make any sense. And yet the fact that people spend sometimes the first 2 or 3 weeks of a programming class teaching them how to set up their environment and get things on their path and check their version on the command line and all that stuff is just a huge waste of time. It doesn't make any sense. This is another big one. This one's another huge pet peeve of mine, right? So people are actively discouraged from copying code off the internet during the learning process, right? They say you can't do that. You can't cheat. They call it cheating, right? And perhaps this is due to some unconscious fear of plagiarism or copyright infringement or whatever. So the vast majority of all teaching materials, even those that are otherwise pretty practical, the online ones, well, they basically actively discourage students from solving the problems given to them by whatever means necessary. So even if that means copying a lot of their code off of Stack Overflow or simply calling a library to do the heavy lifting, whatever it is they're supposed to do, well, that's highly discouraged. To say you have to write everything yourself. You can't use anything that's already out there. See, the problem is that this is the opposite of how things work in the real world. So in the real world, the developer who gets a gold star is the one who saves 2 weeks of dev time on the project by finding something that already solves the problem, rather than the developer who handwrites a completely custom implementation. Because the problem with a custom one is that not only does it take a lot longer, well, you also have to test and maintain it over time internally. That's your responsibility now. So in fact, if there is a free, actively maintained, pre-built alternative that solves the problem, and you as a developer know that, well, if you know that, and then you still decide that you want to go do your hand-coded approach, well, you're going to, at the very least, get a nasty tongue lashing from management because they're going to want to know why you wasted so much time and money doing something that was completely unnecessary. So when your time is billed at over $100 an hour, kind of depends where you work, but this is what your employer might be billing the clients, right? When you're that expensive, you say, oh, it just takes a couple of weeks. Well, a couple of weeks for your client is thousands and thousands of dollars. And so this is why I'm harping on this point here, that in the real world, the best practice is to go steal as much code as you possibly can, in an ethical way. And I say steal, I mean like go use as much code as you already can that already exists rather than writing it yourself. You want to write as little code as possible because it saves your management and or the customer time and money. And so this is the skill that we should be teaching people how to do. Where do you go to find code? Where do you go to find libraries that will help you solve your problems most effectively, right? But we teach them none of that. And instead we say they have to go do everything themselves. It just doesn't comport with how actual software development in the real world actually works. This one's another huge one. So the bulk of actual software development work on real world projects involves interfacing with code that's already been written. So maybe it's an external library, but very commonly it's your application. It's just what the other guy wrote when it started, 5, 10 years ago or whatever. It could be even longer than that. Depends how old the project is. Yet in most instructional systems, so in most forms of computer science pedagogy, students bounce from one project to another project across classes, and they never have to learn the important skills relating to proper documentation and software maintenance best practices. So organizing your code base, not repeating yourself in code. So there's this principle, it's called DRY, D-R-Y is an acronym, don't repeat yourself, right? So reusing code as best as you can so that in the future, if you update something one place, it will automatically update all the other places. Well, stuff like that, super duper important and critical in software maintenance, but not taught, at least not focused on as it should be here, right? Because even in the better things that are mostly only on topic, mostly only teaching you the things you need to know, well, a lot of the time there, they still won't make students go back and use what they've already done. They won't enforce these policies of good software best practices in software development to make them have good documentation and good code organization and structure, because that's just not the priority that they teach and focus on for students. And so consequently, if you ask a student how function X works or class X works from that project that they got a perfect grade on a few months ago, well, they probably won't be able to answer in a timely fashion, much less explain how to use it to a third party who want to make use of your code. So an example in the workplace here is I mentioned that my team uses Angular, and so we've asked these other Angular teams for help. So one of the things that we do is we have this generic like grid that displays data. This is super normal in business applications, right? It's called a CRUD page. Create, read, update, delete. The user wants to see data and be able to modify it. Well, we kind of shamelessly stole the basic skeleton structure from that, from an application that already existed. But there were some things that weren't completely clear when we first started looking at the code. So we went and asked the guys and say, hey, why are you doing this? Why does this function call this thing? And like, why is it being done this way? And by and large, because they had some comments on it and stuff, they could answer our questions. Well, that's the sort of thing that you can't do if you strictly learn according to the way that most resources teach you, because you're never forced to actually go back and look at any code you've written in the past. Again, given how things work in the real world, doesn't make any sense. And so all of these things, not to keep beating the dead horse here, but all of these things are kind of the reason why I'm trying to make this series and put the emphasis where I'm going to try to here, is because the focus here will be learning how to actually program how real world software developers actually do it, right? So that's going to be the idea. Now, of course, I'm sure I'll be imperfect in this. And as I've tried to say here, I'm going to be a little bit biased because I work mostly in full stack web apps. But the point in all of this is that even the much better practical online courses that we've mentioned here will still, sometimes even these suffer from a layer of artificiality, things that make them still be a step away from real world software development. And if your goal is to learn real world software development because you want to be a real world software developer, well, then spending all your time learning these things in a way that's not similar to what you'll actually be doing, it just doesn't make the most sense here. And I want to be upfront here that some things on the internet are completely excellent, right? Sometimes this isn't the case. Some courses are great and 100% practical from start to finish. So the big issue in all of this is that new learners, so people who aren't programmers themselves but are trying to learn programming, well, they aren't going to have any idea how you tell the one from the other. So left to pick things that they study on their own, these people who are trying to learn programming, well, they may still end up learning a bunch of stuff that isn't very useful practically. This isn't the end of the world, it's just time wasted, but time wasted is still time wasted, still unnecessary. And so somewhat ironically then, to be able to select the materials that most efficiently teach you how to program, you already have to be a programmer, right? And actually, this isn't unique to programming. This is true of most professional situations. So if you want to learn, say, electrical engineering, well, then the person that will best be able to tell you the path to take to learn electrical engineering in the most efficient way will be an electrical engineer, right? Makes logical sense. But there's the selection problem here, is that to pick the things that you actually need to know and only the things you need to know in practice, you need to already be someone in the field to do that effectively. So eventually, I'm probably going to get around to compiling a list of things that I think are good, that is practical through and through from start to finish. And that might solve some of this dilemma for people who want to pick up programming, right? And I'm sure I'm not the only person who's come up with this idea before of, curated lists of learning materials and stuff like that. Well, I mean, of course, this will only apply for anyone who thinks that I'm worth listening to, but it's just going to be my opinion. But nonetheless, this is the sort of thing that I think makes the most sense overall long-term, is that you help people who want to learn this field, right? Again, programming is just one example here. You have someone who's an insider, someone who's already been there, already done that can help steer people in the direction of things that are actually useful and practical. So I mentioned at the very beginning here that I'm kind of kicking off this series because I had a friend who asked me to help him learn how to program for his career. And so very first week, when I got into this, I started my friend off learning HTML and JavaScript, right? I had set some links to W3 Schools, which is a useful documentation website about him, because this stuff is basically stuff that I know will be useful to him, especially if he does the sort of thing that I'm going to be, that I have experience in, right? Web stuff. Well, he's 100% going to have to know the basics of these things. In fact, I think most developers will, if you ever deal with web stuff at all. So I started him there just because I'm almost sure that everything that he does there will be useful to him. Nothing is going to be niche. Nothing is going to be not used in the real world. And so I feel like it's going to take me a little bit longer to build a list of learning resources that sticks to that 100% standard that I'm going for here. But eventually, I probably will do that. And the reason for that is because I'm lazy. So in the future, I probably will just start recommending learning resources that I've vetted. So these things that other people have done that I think are actually pretty good, rather than making them myself. And the reason for that is basically just don't reinvent the wheel. If someone else already did it, they probably did it better than me, as I say, because I'm not super special or anything. So there's probably people who are smarter than me, better teachers than me, who've already done a lot of this. And so what I'll do eventually, if I find stuff that I like, is I'll just link to it, right? And eventually, hopefully, that means that I'll kind of just be a glorified link collector. That's going to be the goal. But we'll see. At any rate, I'm kind of opinionated, as you've probably seen here. So I'll probably still make videos of my own on some things to say, well, I disagree with most people, so here's how I think you should do it. Perhaps that will be somewhat the case as well. So this first one got really long. I knew this one was going to be long because there's just a lot to go over here. But this is the outline of the things that we talked about here in this first thing to kick off this series. So we started by just mentioning why I'm making the series to begin with. We talked about some of the ways that this is likely to be different from other things out there, especially in its focus on only the practical stuff, right? Very mercenary sense here. We talked about how you learn a bunch of stuff sometimes that isn't super applicable to what's used in the real world, while at the same time not learning all the stuff that is really used in the real world, and how that's kind of disadvantageous of what you're trying to do is prepare yourself for an actual career in the field. We talked about how some internet resources are better, but generally not the ones that emulate the college environment that has these problems to begin with. Then we went through some stuff that still makes many teaching resources be not quite the same as actual software development. So making people debug with print statements and interact with their apps on the command line only, right? Making people deal with a bunch of icky package management stuff when in reality, most of the time, you don't have to do that much as a dev with regards to that. Like you might have to install packages for your program, but not like the Node version itself, because that's what the IT guys are for. Then discouraging people from copying code and using libraries, even though that's really what most software developers do most of the time. And then not forcing students to go back and maintain their code bases and just jump from project to project, even though in real world software development, you have to deal with code that you wrote a long time ago or code that other people wrote a long time ago. And that's a huge part of the software development process, is this idea of software maintenance. So we went through all of that, and then we ended, and this is the takeaway from today, the point of all of this that we went through, is that the focus here hopefully will be learning how to program, how real world software developers actually program, rather than having any sorts of artificial stuff involved. So anything that is kind of fake, that isn't used in the real world, that's just something, quote unquote, to teach us or whatever, well, we're going to try to avoid that. So in the final reckoning of things, the goal is basically just going to be to cover the things that you really need to know to pick up programming and learning how to code in the most effective way, so that you can get from that point of having little to no knowledge of programming to being ready to jump in with the basics under your belt in any sort of software field. Of course, you'll have to pick up a lot of the specific stuff in your work environment, but getting that foundation that you need in the quickest and most efficient way possible without learning anything that you don't need in the process, while learning all the stuff that you actually need. That's going to be the goal. Kind of ambitious, probably. And as I say here, I'm sure that this won't be the right approach for everyone, that not all of my opinions will be applicable to all people in all circumstances. But the goal is to try to take this efficient, no nonsense approach to it, so that people can learn in the quickest, most effective way possible.